Hey guys, today we're going to review functions. So there are different representations of functions. First example is a mapping diagram, which are just two ovals where you have your x values in the first oval and your y values in the second oval. And what you're looking to see is, do any of my x values have more than one y value? So -3 is paired with 0 and only 0. -1 is paired with 4 and only 4. 2 is paired with 7 and only 7. And 4 is paired with 4 and only 4. So this would be a function. -1 and 4 share this y value, but that's allowed as long as you don't have two arrows coming out of any of your x's, then you're good. Okay, so this one would not be a function because you'll notice that the 6 has two arrows coming from it, pairing it with both 5 and 10, and that is why this would not be a function. And here's another example. This one's a little easier to read because the arrows aren't going all over the place, but we have -1 paired with 0, 0 with 1, 1 with 2, and 2 with 3. So this would definitely be a function because each input has only one output. Another representation of functions would be the table. And the table is pretty easy because you just have to look at your inputs or your x values to see if they repeat. And so you'll notice here, 9 repeats. This is not a function. And this one, look at x's again, go across. Nothing repeats. We have -3 and +3, but that's different numbers. So this would be an example of a function. And this one here, so just as when we were talking about slope, our x's are always in our first column and our y's are always in our second column. So we're only looking here and nothing repeats. And so this would be a function. It's okay if your y's repeat, your x's just cannot. So that's what you're looking at in table format for a function. Ordered pairs are also easy because once again, you're just looking at the x's to see if they repeat, and they don't. So this is a function. This one's not a function because your x's do repeat. So easier to look at. Just make sure you're focusing only on the x values because the definition of a function is that each input has exactly one output. The graphs. So we have to do the vertical line test to see if this would connect vertically anywhere. And if I draw a vertical line, which is a line up and down, then you'd see it would connect here and here. And I can continually do that and see like this would connect all the way across the graph. So this would not be a function. You have to do the vertical line test here. So it's like we're playing connect the dots. So when I connect here and here, and then I go down here, these two dots connect vertically, and so this is also not a function. This one right here is a little bit tricky, but it would have to be an exact vertical line, and even though these are going up, this is a curved line, not a straight line, and so this passes the vertical line test, and this is a function. And lastly, the easiest function to identify are the functions that we've been looking at when finding slope, and that's called a linear function, just meaning that it's a line. So if you have a diagonal line that's going up or down, so it could have a positive or negative slope, those would both be examples of functions.